is instant response, and there's not much left of this course, which happens. The second half of the course in these fall semesters is a lot less than the first half, and next week the class is canceled because we're going to this contest, the pen testing contest. So that lowers it even more. And by the way, I changed the grade scale because there's less total points in the course than I anticipated since I had to cancel a couple of classes. So let me just point that out. I don't think anyone will complain because it's gotten easier to get a good grade. But anyway, I revised the grading. There used to be 500, and there used to be 645 points required. Now there's only 615 points required because there's one less quiz required and one less project. So there's the totals that you need to get various final grades, and they're all lower by maybe 20 points than they used to be. So anyway, I know grading is important. It's that time of year and people are worried about it, which is fine. And all right, so today we're down here and we want to look at, well, I guess Chapter 12, Part 1. I don't know. Actually, I was planning on just doing a lot of demos today, but I think I'll take a look at Chapter 12, Part 1. Well, wait, I should refresh this. I updated that. There we are. Well, I hadn't thought of that. I'm not going to change this again. Okay, I'll just do the demos today. I won't bother with the chapter of the book then. And let's do a few of these demos. IR 350. All right. Go to projects. IR 350 is the last required one, quite important. Although points are points. So somewhere in here is 350. It should be Zeek. There it is. All right. So, all right, we're already recording, so this will do the Zeek Interactive Tutorial. This Zeek is a defense mechanism intended to replace firewalls. They developed it at Lawrence Livermore Lab in Berkeley, and at that time they called it Bro. And for some reason, I think the name Bro was already in use or something, or maybe they thought it was too sexist or something, so they named it Zeek. And also, for the first several years of its existence, they said, this thing is incredibly powerful at protecting networks, it's great, but there's no documentation at all. They seriously said, oh, if you want documentation, just grep the source code. And I'm like, are you out of your mind? But this is what tends to happen with open source projects. The developers all work on it, and they only think about other developers. And they think everybody can read pages and pages of source code and understand them, and they don't remember there's some users that can't do that, that would still like to use your product. So they finally wrote documentation, and they made really good documentation. They made an interactive tutorial where you can practice using it without installing anything. You know, they went from like 0 to 100 in the documentation, which is, it reminds me of Nginx. You know, Nginx came out, it was written by criminals to manage botnets because Apache can't handle 1 million users at once. It maxes out at a few thousand. So they got rid of most of Apache and thinned it down and made a web server called Nginx. And then people started using it, and for a while there was no documentation except in Russian. But eventually they became more professional too. So anyway, this is really great. So you can learn, the thing about Zeek is it's a packet filtering system and you write code to filter it. You can customize your own code in this little language. It looks a lot like Python. So when you start Zeek, it runs Zeek init, and when you end using Zeek, it does Zeek done. So here it just prints hello and goodbye. And so you can run this. If you run it, it'll run in the cloud, and here's the output, hello and goodbye. And it has logs that show you it did not catch any packets while doing this. And the amazing thing about this is you can practice on the tutorial, and you can even feed it PCAPs from yourself. You could use this to analyze PCAPs if you wanted to. Anyway, so this is the first bit of the tutorial, and there's just a lot of these pages which are good. So that's hello world, and so loading scripts. You can load in scripts from other files. So here it's going to load something from MISC dump events. It loads a script. This will print the events that Zeek generates. And there's some default paths defined by where Zeek hides things. And notice the folder name is still Bro, because that was the original name of it, and they didn't update all that. So let's run this, and this should just print out some, it prints out where various things loaded. These are various parts of Zeek that load from these folders, which don't seem to contain Bro anymore. Anyway, here's all the pieces of Zeek loading, so that's not too exciting. And then there's functions. So here you have a function that will emphasize something by putting stars around it. And this, by the way, is I don't know if this is Python, but it's very much like Python, because in Python you can define parameters and you can define a default value, so you do not need to put this parameter there. If you don't put anything there, it'll be a star. And the emphasize will just put that character before and after the words. So here it's going to emphasize yes and emphasize no, specifying an underscore. So if we run that, it will just print yes with the stars around it and no with underscores around it. So this is just formatting such, but it shows you the structure of a function. And then you have variables. You can define variables here. We're going to print x and y. Now here I think we're going to have trouble because I think, go global x. This will be available everywhere. So x will work. Oh, and y is defined, but you can't change the value because it's a constant. This again is like a lot of other languages like Rust and like Python. So if you have a constant variable, you can't change it. And so, run the example for this exercise. So what it's going to do is this Zeek init is going to print x, and x is a global variable, so it'll find it. It's going to define y. It's going to define z and then print it. But it's not going to print y. And here it's going to print x, so that's fine. So this way it should run just fine. It should print a few of those strings, and so it does. Now, if I try to put in errors, like here, I'm going to try changing y and run that. Now it should complain because you can't change a constant. So we should get an error message, and there we are. And this reminds me a lot of modern languages like Rust, where it gives you nice, helpful error messages. You can easily read this and understand exactly what's wrong, which is very helpful. So let's get rid of that and comment that out again. And then they say try printing z down here to see another interesting error message. If it tries to print z, that might look good, but the problem is if you define a variable inside a container, it only exists inside that container. So z only exists between the opening curly brace and the closing curly brace. It doesn't exist down here. Now, if you put it up here as global, it would exist everywhere. But if you put it inside something, it has a scope, and the scope is just the container it's in. And that's true of almost all modern languages. And so that's the problem, unknown identifier z. Yeah.
Question about the constant.
Yeah.
If the constant can't be changed, then why is it even there? Because I don't see it involved.
No, they could have used it, but they didn't. Yeah, you could have printed y too. Yeah, that's right. Go ahead.
Can I share something? Can we say include connu stdu include stdu include? We should say include stdu that h include connu.
Oh no, no. The only. Well, that's a good question. There might be libraries to include to get more functions. Now we're just doing the basic functionality. I think there probably are libraries, and there's probably some way to include them, but I don't know. It's a good question. Yeah, then we got data types. Here you've got a static type system, so you've got locals and the type of variables it holds is fixed with type inference. So, which you can define what data type. So here we are, x is a string and y is an integer. X is a large integer, y is a short string. Okay. So now before, we just set x equal to a string without telling it was a string, and it would figure out from context that it's a string. So that's loose typing, where it will figure out what the type is. That's kind of sloppy. It's much more controlled to specify exactly what kind of variable everything is, rather than letting it guess. But anyway, y is large. Now we're going to do pattern matching. This is grep type pattern matching. So this is the delimiter, the slash and the slasher, are the beginning and end of the pattern. And here's the pattern, 1 or 2 or 3. So that will equal 2. That's going to be true. And this does not equal 1s because 1, 2, and 3 is not one of those 3. 1s is not included. Here's 1s. And in 1s, that's interesting. So you can have 3 choices. If any one of these is included in there, then it's true. So 1 is included in 1s. So this is true. That's interesting. I haven't seen that done in Python. And here we have, I think the brackets mean 1, 2, and 3. Let's see what the brackets, the square braces mean. Okay. Regular expression using Flex's syntax. Okay, there's all these different kinds of regular expressions to make sure we're all nuts. Let's find out what the square brace means. Okay, either X, Y, or Z. Okay, so it's another way to do the OR. So this should match 1 or 2 or 3, and then have anything after it. So 2, 2, that should be true, but 4, 4 is not going to be true. Okay, so this, by the way, all right, let's run this one and see, understand it, and then I think we can modify it now. So, whoa, error. Overflow promoting from unsigned double. Okay, something went wrong here. Okay, so that integer is too big. I wondered about that. Let's see if they're going to talk about that in the documentation here. There seems to be some limit to how big a number you can store. The full reference on types. Let's take a look here and find out how big an integer can be. I probably need to make this long int or something. That's what it would be in C. Let's see, here's the names. File, int. Okay, int is a numeric type, okay. Are we going to have, oh good, there's more information about them down here. Let's find out what's going on. Apparently there is a limit to how big something can be in the int type. So let's find it. Any bool count, double, enum. Oh, they're alphabetical. Okay, so no, they're alphabetical. So F, G, H, I should be down here somewhere. Let's try int. Okay, let's try this. Double. Yeah, I don't know if I can put a space before it, though. There, I found that in. A 64-bit unsigned integer, well, that should be able to hold numbers up to 16 billion billion, which that number was still bigger. Okay, there's a limit in the size. There's int, okay, and there's double. All right, so I think 16 billion billion is the largest number because 2 to the 32 is 4 billion. And 2 to the 64 is 16 billion billion. So that's only about 20 digits. And I think they had more than that here. Yep, so this is a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
20 digits?
Yeah, so that's 16. That should fit. But anyway, if it's really an int, let's try making it a little smaller and see what happens. Then we can run this. Now it runs. Okay, so there's some limit, and we were near the limit. Here's a short string. True, false, true, true, false. And that was, this is true because the 2 is in there. This is false because 1 is not in there. This is true because 1 is in here. And here, what I wanted, so 2 is included in that, and 4 is not included in that. And the thing I wanted to see is I don't think we need these square braces. If I understand it correctly, I could do this, and it would be exactly the same. Stuff inside square braces are treated as OR, single digits OR. So that should, the next to the last one should still be true. Let's see if that's true. Yep, oh, the next to last one is now false. Oh, that's interesting. Oh, well, this mess, the dot star might be a problem. I see. That's probably the problem. If you want to add this junk at the end, I think you maybe use parentheses for this. Because the problem is, only the 3 had the dot star after it. So the 2 had to be alone, and this 2 is not alone. Now, it should be any of these 3, and that, if parentheses mean what I think they mean. Let's see if this works. Yep, now it's true. Okay. So this expression here is equal to that expression there. All right, that makes sense. All right, anyway, so that's pattern matching and such. And, all right. And so let's try another one here. Then the operators. All right, so we have functions and variables, and here's operators. Let's see if I can make this border. I can't move it. We had a plus b, a minus b, multiplication, division, modulus, unary plus, unary minus. Those are the same. Increment and decrement. Okay, those are all exactly like you'll find in every other language, C and everything. And then a equals b assigns b to a. This Adds, that's interesting. This adds B to A and puts the answer in A, the same as it would in C or Python, and that's subtraction. Here, 2 equals for comparison because 1 equal is variable assignment, the same as every other language. Not equal, less than. Okay, these are all very much standard. And here's not, logical and, logical or. Okay, and this is the one we saw before, inclusion. A in B, if B. So that's okay. That's all very much like Python. Absolute value is the length of something. It's the absolute value of a number or the length of something that has length, like a string. Index. Okay, this is exactly how Python does it, from I to J. So if you have testing and you print from 2 to 4, that means you go 0, 1, 2, 3, and don't include 4, so you get ST, just the way Python does. You start counting at 0, and you go up to but not including the second number, so it's ST. All right, so it's very much the same as Python, all right? And so here, try to figure out what happens if you use numbers as strings and compare them with ints. Well, yeah, that would be fun. So that's a common one. So if I have A equals 1, and B equals 1, and then I print A equals B. And I need a semicolon after each line, apparently. All right, that should be false, because the string is not equal to the integer. All right, and now, okay, what did I do? It didn't like this. Wow, that's interesting. How can that be wrong? Oh, maybe I need double quotes. Oh, I'm used to Python or PHP where you can use either single or double, but I noticed they're only using double quotes for strings here. Maybe you have to use double quotes in whatever language this is. Let's see. Nope. Unknown identifier A at or near A. Oh, when you define a variable, I think you have to use like def or something. I think I was back here. You can't just set it equal, you have to define it. Const y local. Yeah, they have a variable. Well, here's x equals by, though. Now, just a minute. There they totally did exactly what I'm trying to do. All right, let's go forward and see what I'm doing wrong. But like I say, this is a great tutorial. You can practice all these things in a nice, safe environment. So they would let me do this here. All right, maybe I forgot the semicolon. So I tried to do A equals, quote 1. Let's see if it complains about any of this. And this, by the way, is the general, there we are. It doesn't like X. Okay, let me go back and find out what's going on with that X. Maybe you have to define it first, and they did define it. Here, it's global. I think you do have to define it, and you have to give it one of these words like global or constant or local. That's why. Okay, that's interesting. And, yep, a local and global. Yep, okay. That's interesting and actually a good idea to make you always specify whether it's local or global. So what I need to do here, to do what I was trying to do, is local A equals, quote, 1, and local B equals 1, and now print A equals B, semicolon. All right, that might work. Type clash, no, that's right, type clashing comparison. They're not equal. I thought it would just say false, but instead it says you can't compare them, which is a reasonable thing to say. That it's very unlikely that you actually want to do this. That's good. And another thing that obviously should fail is if I try to add, if I set C equals to A plus 1, it should complain about that. You shouldn't be able to add an integer to a string. You couldn't do that in pretty much any language. I should get some kind of, yep, I'm getting an error. Unknown identifier C, right, okay, fine. I got to have local, but you're still not going to like it. There we are. Now I get a different one, requires arithmetic operands. This is, okay, so anyway, that's just what you'd see in any other language. Trying to add a string to a constant, to a number, will usually not be allowed in any language. All right, and then you have if, as usual. Here's if, just like before. If C equals X, then do something. And so, let's see, X is 3. for C in 1, 2, 3, 4, 5, this is nice. This is just the way Python works. This is going to do it for C equal the string 1, 2, 3, 4, 5. And so if C equals X, it'll print this. Otherwise, it'll print, I'm looking for X, not C. Right, and this is the same as Python. You can just put multiple things on a line separated by commas. So that should be pretty clear. Yep, I'm looking for 3, not 1. Found it. I'm looking, yeah, that's good. So that's good. It shows you a few things. The for loops are just like Python, except you don't have the colon. You have in Python. Notice, by the way, there's a semicolon here, but there's no semicolon here and no semicolon here, because you're defining something with a container, and you only need semicolons inside there. Also in else, there's no semicolon. These sort of flow control commands don't have semicolons. It's the ones that execute something that do. Anyway, so if statements look pretty normal, all right. And so you got for loops, which we just used. And for character in ABC print, that's just, if we're going to do letters A, B, and C, you can iterate over any collection. I'm very used to this from Python. Yeah, there we go. We just A, B, and C. And while loops are really just another way to write for loops. While I less than 5, print I, increment it. Okay, that'll print from 0 to 4, I think. And then it will no longer be less than 5. So this will go from 0 to 4, I think. This will go I%2 is not equal to 0. This is only going to be true for odd numbers. Even numbers that will then locally finish up. Print nope. All right. If finish up. This part here I'm having a little trouble understanding. Let's see. Finish up starts with F, which, by the way, is not in quotes. Oh, the F stands for false. Oh, that's rude. So this is the way to define a Boolean variable that's false. That's interesting. They don't have Boolean variables in Python, but they do have them in Fortran and stuff. Anyway, so that's false. If finish up is false, then print nope and add 1 to I. And I here ended up at 5. It's going to stop as soon as it's no longer less than 5, so it's going to be 5. So this condition is going to be true for 5. And this condition will be true, so it will print nope, change to 6. And I think next we'll go back to here, where this will not be true. I think it'll be in. This part here confuses me. Let's see what it does. All right, the 1, 2, 3, 4, 5 I understand. Nope and 6. The nope I understood. When it enters at 5, it's going to end up here. And next we'll go back to here. But it has incremented, so it's now 6. So this condition is no longer true. And so where's the end of the while? Oh, that's why. And the while loop is false. Okay, so it's only going to run this loop one time for the value 5. Then it's going to be 6 because of the increment, and this condition will be false. It'll go down here and print the 6. Okay, that's a little screwy. But anyway, gets you to see while and if statements work in for loops very much like they do in other languages. So now we have everything. So now you want to write a program to remove every letter E from an arbitrary string and print the numbers from 1 to 100. Fizz and buzz. All right. And they got solutions on the next page. I'm not going to struggle with that. But I want to get down to the PCAP demos, which are down here someplace. I think it might be this one. Yeah, now we have the basic concepts. Yeah, that's the question. Now you can create a list of subnets as your local subnets. You can write a script that will process these packets. And you have to load this traffic sample exercise, PCAP. So, that's right here, exercise traffic. Okay, fair enough. So let's go back a couple and see if we have examples of how to process, how to process packets. This is a solution for that one. This is still processing strings with fizz and buzz and such, and that's not that interesting. Here's the switch statement. This is still processing integers and strings and stuff. I want to see how to handle packets, and it's got to be in here. Here we are. The event, I think, is where we are. Okay. Now, Events. Okay, you can define an event and have it trigger on an event. All right. And let me check my instructions. I have some questions here. Variables, primitive data types, operators. Yeah, we did all that kind of stuff. And loops and switches, composite types. Okay, exercise traffic P-type. From the exercise 2. Right, I think we're just going to look at the example, the solution for the exercise is the way to get a clue how to handle packets here. So here's exercise 2, and here's the solution. Right, and so now we can see how it handles networks. Here you define a set of subnets. These are the local subnets in your network. Whoops, somehow I moved on me. All right, and now, okay, and now here's your inside networks and your outside networks. It's a set of addresses. So address must be a data type, which is not obvious. Okay, we're going to count, if I count the connection, so CID orig H in local subnet. This must be a way to get the header, inside networks and outside. So not too obvious, but that's why I need to look at this example to see how to do it. And this you see what you have to write to process packets. And you could upload your own packets and run them through these scripts. But anyway, there's a few examples where you just practice writing those. And I think that's as far as I want to go in the demonstration here. This is real good for you. And if you're not interested in programming, you can do this the easy parts at the start and not worry about the parts at the end. But you can learn how to program PCAPs. And of course, it's going to come with some default scripts. So that's Zeek here in the tutorial. And let me stop this one and make a separate recording of the next one.